Hi everyone. My name is Tobias and I'm the design lead for Google Fonts. On the Google Fonts team, we believe that everyone should be able to access information and express themselves, no matter their language or ability. Text is an integral part of any digital experience and tends to make up a large portion of what's shown on screen. It is a powerful tool to make your project more desirable and accessible. Today we're going to show you a few things that we've been working on at the Google Fonts and Material Design teams, and how you can use new font technologies like variable fonts to create experiences that feel more personal to your users, and how they can be optimized for increased readability. For this, we're going to demonstrate some of the new typographical possibilities variable fonts can bring, and our new variable icon set called Material Symbols. We're also going to talk about some of the readability research that we're conducting and some of the opportunities that variable fonts bring for better accessibility. First, let's take a look at what variable fonts are. The technology is the result of a collaboration between Adobe, Apple, Microsoft, and Google, and was added to the OpenType specification. Traditional font families need a different font file for every available style, like bold, thin, or condensed. This goes back to when letters were still cast in metal and foundries would create a set of all the letters used in a typeface for every style each. There would be one set of metal letters for regular, one for bold condensed, and so on. But type has evolved since the days when it was cast from metal. Variable fonts provide the ability to use type as software and benefit from the flexibility that digital media can provide. For example, a variable font provides different weights not as a limited set of different font files, but as a continuous range from lightest to boldest, from which you can pick your own custom weight, all from one file. Let me demonstrate this to you using our newly launched Roboto Serif typeface, which we recently introduced as a companion to the existing Sans Serif Roboto that you might be familiar with already. You can see it here in a nice little demo app that we built. Notice the weight slider shown in the side panel. As you can see, I have access to all the weight values between 100 and 900, and I'm able to select exactly the weight that meets my requirements. However, you might have also noticed that there are other sliders in this UI. Similar to the weight slider, the width slider gives me seamless access to all the different width styles of Roboto Serif. Also notice how I can now combine any weight with any width. I could also choose Roboto Serif as a very thin and wide font, or as a very bold but condensed font, or anything in between. What's represented here using these sliders is called variable axes. Let me show you another one called grade. I'm going to demonstrate the grade axis using another typeface we recently introduced, Roboto Flex, which is the new generation of the classic Sans Serif Roboto. I'm also going to show you this one using the recently launched Figma support for variable fonts. Now there is a new type settings panel here in Figma next to the text controls that provides access to all the axes a font family supports. Grade works very similar to weight. However, it doesn't impact the width of letter shapes like weight does. That means it can be applied without causing text reflow. Notice how these paragraphs don't change any line breaks, even though the weight changes dramatically. In interaction design, this could be used for visual emphasis on a link on hover, for example, without any of the changes to your layout you would see with typical bold text running wider. Roboto Flex is special because it has a number of axes for fine-tuning your text. These are referred to as parametric axes, as they provide access to all the different parameters of the design of the typeface. They provide granular access to a wide variety of aspects of how the font is rendered on screen, and can be used for fine-tuning readability of text in different scenarios, or circumstances and user needs. We're really excited about variable fonts because they provide so much opportunity to make sites and apps more desirable and expressive. For one, they can make your website faster by providing noticeable file size savings compared to traditional fonts, where several different font files are required for the use of different styles. But the benefits aren't just limited to performance improvements. With variable fonts, type has arrived in the world of software, without the constraints inherited from the physical world. This new flexibility opens up a whole new opportunity space for expression. The combinations of styles we mentioned earlier, like the ones between weight and width, aren't possible with traditional font files. Type designers offering variable fonts are introducing entirely new axes, like the wonk axes, to make fonts more or less wonky, as seen in the typeface flounces here. Or the recursive font that has a new axis to make letter forms look more or less casual. As these variable axes can be manipulated programmatically by design tools or by code, they provide entirely new opportunities for transition and motion. We don't have to decide between a condensed typeface or a Y one anymore. Our user can now literally experience both or anything in between. This new level of control of how text renders on screen will also help to increase readability for everyone. We will discuss readability a little later in the talk some more. Google Fonts already provides a large selection of variable fonts that you can now use in your Figma designs. We've also created a very handy interactive demo for you to try out and experience variable fonts in the context of a Material app. The demo will also show you how to apply these new features in CSS. I'm now going to hand over to Sehi, who will talk to you about icons.
Thanks, Tobias. Hello, I'm Sehi. I'm a senior designer leading iconography for Google Fonts. Material Design Icon is an effort from the Material Design System to create and maintain an open source repository of high quality and user-friendly icons. We are continuing to evolve our iconography to the next level. Tobias introduced how we developed the Roboto font family using variable font technology. But the technology isn't just for fonts. It can be applied to icons too. I'm excited to share our new cutting-edge iconography called Material Symbols. Material icons are no longer the static vectors that designer draws line by line. We redesign all of our material icons into a set of 3 variable fonts called Material Symbols. This is very powerful because it allows one symbol to contain multiple stylistic variations. Each of the new Material Symbol fonts has 4 customizable attributes called axes. An axis is a typographic term referring to a continuous range of visual options. Each symbol contains 4 axes: weight, fill, optical size, and grade. Let's look at Material Symbol in more details. Material symbols are available in 3 sets: outline, rounded, and sharp. You can pick any of these styles to best suit your brand. Choosing the icon set that feels right for your product can tie the content of an interface together, enhancing the cohesive branded feel of your product. Each style supports 4 adjustable stylistic attributes. First, weight. Weight defines the symbol's stroke weight with a range of weights between thin and bold. Using weights, you can choose lighter or bolder weights that work for your app or your website. You can use this better pair your brand typeface with the Material Symbols. We design our symbols with similar considerations to typefaces because they often appear alongside text. For example, using weight, you can now apply the same weight to type and symbols. Second, there's fill. Fill is another primary attribute that gives you the ability to transition from an outline style to a filled style. You can simply use one of those styles entirely in your design, but you can also use the fill attribute to express a state transition such as selected and unselected state for a bottom navigation bar like this. Next, optical size. The symbols are offered in 4 sizes: 20, 24, 40, and 48 dips. We've done this because we want the image to look the same at different sizes. And for that to happen, the stroke weight has to actually change in a subtle way as the icon size changes. The optical size axis offers a way to automatically adjust the stroke weight when you increase or decrease the symbol size so that it looks optically correct at every size between 20 and 48 dips. Lastly, grade. Variable font offers accessibility benefits. Using grade, you can fine-tune your weight setting to optimize for a dark theme or a high emphasis mode. Both weight and grade affect the symbol's thickness, but adjustments with grade are much more granular. You can use grade for different needs. To reduce glare for a light symbol on a dark background, use a low grade, such as -25. To highlight a symbol to subtle way, apply a positive grade, like 50. Our eyes sometimes do funny things. A light text on a dark surface always appears to be bolder. Using negative grade to moderate this effect can give the text better optical parity between light and dark themes, so the user experience is just as good in dark mode as in light mode. To recap, today I briefly walked through the 4 customizable attributes of material symbols. My hope is that you will take these ideas forward and use a wide range of flexibility to your benefit. You can download material symbols by visiting fonts.google.com/icons. Using the customizable panel, you can preview, browse, and download the symbols for your product. With the Figma plugin, you can easily search and add symbols to your design. Please refer to the link to download the plugin. Learn more about material symbols and its best practices by visiting n3.material.io. I'm now going to hand it over to Michael, and he's going to talk about some recent research into readability.
Thank you, Sehi, and thank you all for joining us. My name is Michael Gilbert, and I lead research for the Material Design System. Tobias introduced what variable fonts are and how you can use them. And Sehi introduced symbols and again showed some of the new possibilities for expression. Now I'm going to share how we've researched variable fonts to look at how we can understand how these changes of grade, optical size, and more impact the accessibility and the readability of your text. For instance, we did an experiment to identify how grade impacts readability, and specifically, how readability might be different across light versus dark modes. Since Tobias and Sehi already gave an overview of grade, I won't go into that in detail here. The one thing I want you to remember is that grade is similar to weight, but it doesn't impact the width of letter shapes like weight does. You can see that in the example here. As the grade increases, the stroke thickness increases, but the width of the whole string stays the same. In this experiment, we wanted to see if grade would have an impact on readability when you're in light mode versus dark mode. Because if there's a significant difference between readability between those two, we'd want to update the material guidelines to make sure people are using the right grade in the right mode. Or if there's not, we could update guidelines to clarify that grade doesn't diminish readability when you go between light mode and dark mode. And what we did was pretty simple. We created an experimental prototype and asked a bunch of people to read 2-word phrases as fast as they could, and then to type those phrases from memory. The whole process was really fast, and it looked a little bit like this. We made sure the words we use should be understandable by most people using something called the Dale-Chal word list. And we made sure not to worry about uppercase or lowercase. The whole thing was case insensitive. And last, we also made sure to allow people to misspell words. I still can't remember all the rules around when I before E except after C, if you remember that elementary school rhyme. And we did that using something called the Levenshtein distance. In the end, we can explain all our results in one graph, shown right here. And in the interest of time, I'll get straight to the takeaways, and we've got 3 of them. First, we did not see a significant difference in readability when varying grade in dark mode. So if you're focusing on dark mode, you may be able to modify grade without impacting readability, with the caveat being in the context in which we studied, which is short phrases. Second, we did see a significant difference when varying readability in light mode, but only between the highest and the lowest values. Higher grades may improve readability in light mode. And if you're concerned about readability being the same between light mode and dark mode, at the default grade value of 0, it looks like grade won't significantly differ between those two modes. Again, with a caveat given short phrases, the setup that we had in our study. And last, at least at the highest values of grade, light mode was more readable than dark mode. Now, this is surprising to some, and something we'd call out sometimes because dark mode is often more preferable than light mode. But when it comes to what's more readable, in the context we tested of short strings, light mode was more readable. And that's just one example of some of the research we're doing. My colleague, Hilary Paulman, who's the research lead for Google Fonts, is also leading Google research in a partnership with the Readability Consortium, which is a cross-industry and academia group of researchers working to find out which fonts are most readable and which settings help people read better. They're doing research at scale in all sorts of contexts, including long-form and short-form reading. And what they've already been able to show is how variable readability is at a personal level. Now, this graph may look a little intimidating, but I'd like to use this to communicate one thing. Readability is very personal. What you're seeing on the graph is the readability of 5 different fonts, with each horizontal row representing a single person, and each of the circles on those rows representing the readability of a single font. And for reference, the blue circles are Times New Roman, and the yellow circles are Noto Sans. What this means is that first, there might not be one typeface or style that works best for everyone. But second, I think this research clearly shows that we have the tools to identify the right typeface and the right style for any given individual. So no matter how we vary a font, we can determine how that variability may help or hinder readability. And what this means is that with variable fonts, you now have a whole new set of dimensions that you can adjust to make experiences more usable, more accessible, and more beautiful, no matter what your users are doing. For example, consider an experience when you're looking at a timer on a device, and potentially very much like the timer here. And if you were right next to the screen, the text would be smaller, emphasizing the visuals and the physical controls. But real life is never as clean as a tech demo. Have you ever noticed that? You back away from the device and the screen pretty quickly becomes illegible. But let's say that you have a device that is both using variable fonts and measuring your distance from it. So when you walk away, the text becomes larger so that it is legible no matter where you go. And what's really magical here, in my humble opinion, is we now have the tools to not only make accessibility sensitive to the individual person, we have the ability to make accessibility sensitive to an individual situation. What's really magical here is we can do that same thing in many other situations. For instance, when you walk outside, we can adjust the grade of the text on your phone to be more readable in direct sunlight. And last, we'd like to share some of the tools that we use when we think about readability and accessibility. Like what we use to measure how legible text might be if you're 3 feet away versus 10 feet away. And we'll include a link to this blog post at the end of this talk. Or how to determine if a combination of variable font dimensions are more or less readable in any given context. And again, we'll link to that resource at the end. So if you're ready to jump in right now, I'll pass it back to Tobias, who will share a bit more on how you can get started. Thank you, everyone.
Thank you, Michael. So, Today, we showed you some exciting ways in which you can use new type technologies in your projects to make them more desirable, personal, and accessible. We had a look at variable fonts with the new Roboto Serif and Roboto Flex font families. We also had a look at our new variable icon set called Material Symbols and the new opportunities to improve readability for our users. To try all this out for yourself, please visit our new demo app at goo.gle/about-variable-type. Or check out the code lab called Migrating to Variable Fonts. You can also find all the fonts and icons we showed you today and a lot more at fonts.google.com. Thank you.